Good evening, everyone, and welcome to the webinar or virtual public informational meeting for project number 111-125, replacement of Bridge 055664 on Taft Pond Road after the Mashamoquet Brook in Pomfret, Connecticut. The contact and project information is below. This is how to use closed captions and subtitles in Zoom. There should be an option button below at the screen below. My name is Mark Burns. I'm the project manager for the Connecticut Department of Transportation for the local bridge programs, and my contact information is shown below. I now have to read this slide regarding Title VI and civil rights. No person shall, on the basis of race, color, or national origin, be excluded from participation or subject to discrimination in development of this project. We highly encourage you to fill out the voluntary post-meeting survey located at the link below or using the QR code. There is also a link to access civil rights information. A recording of this presentation will be posted to YouTube after the event, and closed captioning, including non-English translation options, are available on YouTube. Here's a slide regarding the department's stance on Title VI. As a notice to the public. This is also available in Spanish. The goals for tonight's meeting are to interact with the project team, to explain the federal local bridge program Design Managed by State or DMS program. We'll have welcoming remarks by the first selectwoman for the town of Pomfret. We will also introduce the project team. And then there'll be a formal presentation of the design progress, which will include explaining the condition of the existing bridge and the need for its replacement, and a recommendation for a viable proposal. Please bear in mind that we are currently at 30% design, and this is the time when we go to the public to solicit input. Following the presentation will be an open forum for your questions. Here is how to use the Q&A during the Zoom. You can select the Q&A tool at the bottom of the Zoom webinar window, and then the window will pop up, and then you can type in your question and click enter, and it will be put into the chat. If you're an audio-only participant, please dial *9 to raise and lower your hand. Here's how to interact with the project team during the informational meeting: by email at dot-flbp@ct.gov, by phone at 860-594-2020. This is a monitored voicemail line, or in the Zoom Q&A chat, which will only be available during the live Q&A session. We also encourage you to visit the project webpage located at portal.ct.gov/DOT-POMFRET-111-125. Please note the comment period will be open until October 31st, 2023. So this project is funded through the Federal Local Bridge Program, Design Managed by State, or DMS program. In the past, the Federal Local Bridge Program was an 80-20 split, with 80% federal funding for design, rights-of-way, and construction with a 20% town match. Under the DMS and through the infrastructure bill, design, rights-of-way, and construction phases are now funded with 80% federal and 20% state funds. Design, right-of-way, and construction phases are at zero cost to the town. Now, even though the department has taken on the design on behalf of the town, it is still a full partnership with the town, and we coordinate at all project milestones to solicit the input. The goal of the DMS was to provide a streamlined approach to design using DOT resources to aid towns in keeping their bridges in a state of good repair by effective use of funds, to decrease typical design time from 48 to 60 months to 24 to 36 months, and when possible, to utilize accelerated bridge construction or ABC techniques to shorten construction duration. The goal is to also increase the number of municipal projects delivered to construction each year. I will now turn it over to Maureen Nicholson, First Selectman for Town of Pomfret. Maureen?
There we go. I remembered to unmute myself. I want to welcome everyone that took the time to join us this evening. I think you'll enjoy this presentation. I thoroughly did when I heard it last, and I learned a lot, and I hope you will too. And please don't hesitate to ask any questions you might have. Thank you.
Thank you, Maureen. I will now introduce the project team. Our division chief of bridges is Bart Sweeney. Our principal engineer of the consultant liaison group is Derek Lassard. As I said, I'm Mark Burns, project manager. Andrew Shields is project engineer, who is on vacation this evening, so he couldn't be here. From the Office of Rights of Way, project coordinator Zachary Garino, and then Kathleen Erickson, who's an assistant project coordinator. And then from our consultant liaison engineering firm, CHA, is Anand Sasadri, project manager, and Rochelle Clark, project engineer. This slide depicts the various structural elements of a typical bridge. On the top is the deck and parapet, which is the driving surface or walking or bicycling surface. Then the parapet is there to prevent vehicles or pedestrians from falling over into any hazards below. The deck is supported by beams, otherwise known as the superstructure. These will usually be concrete or steel. Supporting the superstructure are abutments, as shown. There will also be wing walls, which will support the soil behind the structure and keep soil erosion from happening. These are also known as the substructure. And in some cases, depending on the length of the bridge, there will be a pier or multiple piers, depending on span. Bridges are rated on a scale of 9 to 1, with 9 being in excellent condition and 1 being imminent failure. Ideally, here is a slide. Okay. Ideally, we'd like to get projects started before they reach critical condition, but obviously situations arise where we're not able to do that. So we try to act as fast as possible. This slide depicts examples of concrete deterioration as shown over various time periods. The top left shows efflorescence. This is a chemical reaction when concrete reacts with the material inside and causes that white substance to start leaking out. Honeycombing is a situation where concrete is subject to several freeze-thaw cycles, resulting in the concrete to start popping off, basically. Scaling in the top right is when concrete has been damaged by plows or vehicles. Map cracking is a type of cracking that occurs during settlement or excessive loads. And then spalling is when the situation has gotten so poor that the concrete is actually falling off from the reinforcing steel beneath it. I will now turn over the presentation to Rochelle Clark. Rochelle?
Good evening, everyone. In tonight's presentation, we are specifically discussing bridge number 5664, which is Taft Pond Road over Mashamoquet Brook in Pomfret. In this aerial view of Taft Pond Road, north is oriented to the top of the page, and our bridge is located here in the middle of the photo. Taft Pond Road runs north and south and has several bridge crossings, not just over the Mashamoquet Brook. This particular bridge is at the southern end of Taft Pond Road and is the one that's closest to Route 97, which you might also know as Hampton Road. In this area, the Mashamoquet Brook runs from west to east below the bridge. This is a photograph of Taft Pond Road looking toward the south. It's a 2-lane road that is 22 feet wide, and this road sees a small amount of vehicular use with about 168 cars crossing the bridge each day. The speed limit on the road, which is also the speed that the road is designed for, is 35 miles per hour. Cars do move quickly through this area, and our traffic counts show that the 85th percentile for the speed is 46 miles per hour. This means that about 85% of the cars traveling across the bridge are going 46 miles per hour or slower. The classification of the road affects certain design criteria that highway engineers must use, and this road is classified as a rural minor collector. The existing bridge was constructed in 1900, which makes it over 120 years old. The bridge was rehabilitated in 1996 and then again in 2021. It's a single span bridge, which means that it doesn't have any intermediate piers, and it spans from abutment to abutment. The length of that span is 22 feet. And when we talk about the span of the bridge, we're often referring to the structural span, and that goes from approximately the middle of one abutment to the middle of the other abutment. The bridge's superstructure has bituminous pavement supported on corrugated metal deck. This is a little different than typical bridges, which tend to have concrete deck instead of steel deck. That steel deck is supported by steel beams that span from abutment to abutment. The substructure has concrete abutments and concrete wing walls. These elements are supported on concrete footings that bear on soil below the foundation. In this photograph, the footings are actually covered up by water, so you can't see them. The bridge currently has weight restrictions. It is posted for 3 tons, and commercial trucks are prohibited from using the bridge. The Mashamoquet Brook flows from below the bridge through a 20.2 foot clear span. So the clear span is slightly different than the structural span, and it's the distance that's measured from the face of one abutment to the face of the other abutment. The width of the river, when it is full but hasn't yet overtopped its bank, is referred to as bank full width. In designing a bridge, we aim for the bridge, the length of the bridge, to have a clear span that's 20% longer than that bank full width. For the Mashamoquet Brook, that value is 36 feet, so that's significantly longer than the existing 20.2 foot clear span. The bridge restricts the amount of water that can flow in the brook, and so the additional water that builds up on the upstream side of the bridge causes the surface of the river to rise. And that surface of the river is approximately 1.8 feet higher than it would be if the bridge wasn't there. And that's when we're considering a 100-year storm, so a fairly big storm. This criteria is generally restricted to 1 foot above natural conditions. During that same large storm for this bridge, as I mentioned, we're designing for a 100-year storm. The river will rise all the way up to the bottom of the beams. Since there's not any underclearance, it means that any debris that's floating on the surface of the river is going to push up against the side of the bridge. Typically, designers want to have about 2 feet of underclearance to allow that debris to move underneath the bridge. Again, you can see that we've got a dashed line here showing the bottom of the steel beams, and that's where that 100-year water surface elevation would be. We also look at how high the surface of the river is compared to the top of the roadway. This is called freeboard, and in design, we aim to have at least 1 foot between the surface of the water and the top of the roadway. Finally, the bridge is considered scour critical. This means that in a really large storms, there is potential for the swift moving water to carry away portions of the soil that the footings are sitting on. Mark explained conditions ratings earlier, and we can run through those now. As a reminder, the scale runs from 1 to 9, and the higher the number, the better the condition of the bridge element. As mentioned before, the bridge was rehabilitated in 2021, so several of the ratings are high. The deck has a rating of 7, which is an indication of good condition. The superstructure is rated a 6, which means it's in satisfactory condition. Where we begin to see lower ratings is at the substructure level. The footing at the south abutment is rated a 3 because some of the material below that footing has been scoured away. And there's a picture of that later in the presentation that I'll show you so you can see a little bit better what we mean by that. The rating for the entire substructure is actually downgraded to a 3 because of that footing condition. So the substructure is currently considered to be in serious condition. Up here we have the bridge railing, which is noted in good condition. And one of the things that we want to point out to you is that even though our condition rating for our railing is good and received a value of 7, that only refers to the condition of it. The bridge rail actually does not meet current safety standards. Next, we have some photographs showing both the bridge and the bridge site. Starting in the upper left corner, this is a photo of the bridge from the west elevation view. This is where water enters the structure and flows eastward. The top right picture is the east elevation. So again, this is where the water is exiting the bridge. The bottom left picture is a view looking over the bridge to the north. Finally, the bottom right picture is a view of the bridge looking south over the bridge. You can see in the photograph that there's a sign on the right-hand side You can't read it in the photograph, but the sign gives the weight restriction on the bridge, which is that 3-ton weight restriction. And there is a similar sign on the other side for the approaching traffic. On this next slide, the photo at the top right is a view of that bridge rail. As I mentioned before, this particular bridge rail does not meet current safety standards. The top right picture is indicating a utility pole in the distance. It's sort of difficult to see in this picture, but it's good to know that there are no utility wires overhead. These stop quite a way south of the bridge. Therefore, there aren't any impacts to the overhead wires during construction. The bottom left picture is a photo of the steel beams before they were rehabilitated in 2021. And the bottom right picture is a picture of the beam end after the repairs have been completed in 2021. So you can see that the beams are in significantly better shape after the repair work was done. In our next set of slides, this top right photo is another repair that was completed in 2021, showing the connection of the bridge rail post to the fascia girder. The picture in the top right is significant because it actually shows a bit of concrete here at the bottom of the stem of the abutment, and that's actually the top of a scour wall. So in one of the previous rehabilitations, a scour wall was installed to try to mitigate that scour at the bridge. The picture in the bottom left is the one that I mentioned that would be coming up. This is actually an underwater photograph showing the bottom of the footing and showing that there's material that has washed out below this portion of the footing. The bottom right photo shows some additional concrete blocks that you can see in the embankment slope. And those were added to help protect the slope and keep the soil in this area from washing away. These last two photos show Mashamoquet Brook. The left photo is looking upstream, and the right photo is looking downstream. In the first photo, you can get a better idea of what the bankful width of the river is. The river isn't flowing quite full in this photo, but you can get some sense of the distance from bank to bank. And again, that distance is about 30 feet and our bridge is about 20 feet. So the river really has to neck down quite a bit to get underneath the current structure. That's an overview of the bridge as it is today. So now we are going to start looking at what we have for our proposed project. There were several reasons why this project was initiated. The bridge is currently posted, which means that vehicles over 3 tons are prohibited on the bridge. That's something that we want to address. The bridge is also scour critical, so we want to prevent any future undermining of the new structure. The bridge and the approach rail systems need to be replaced. And the bridge also needs to improve the hydraulic adequacy and performance of the bridge. In the end, what we want is to have a 75-year service life for our new bridge. Because this bridge is 123 years old, the best way to address all of these issues is to fully replace the bridge. The new bridge that is proposed is a pre-stressed concrete adjacent deck unit bridge. The bottom photo shows a bridge with concrete beams. This bridge would have a 75-year service life and would require minimal maintenance. The new bridge will be able to carry the required design, legal, and permit loads, which would mean that the bridge would no longer need to be posted for weight restrictions. The bedrock in this area is higher on the south side of the bridge than it is on the north side of the bridge. So the south abutment would actually sit right on the bedrock. The north abutment would utilize piles that extend down to the bedrock. So for this foundation, if we were to have a large storm that would, have the potential of washing away some granular material, the foundation that's sitting on bedrock, there's no potential for any type of undermining for that portion of the structure. On the north, where bedrock is lower and we need those piles to extend down to bedrock, those piles would actually be designed for that scour. And so with the new structure, we would be eliminating that low rating that we saw before where the bridge was getting a 3, and it would no longer be a scour critical bridge. This bridge would have an open bridge rail. Both of the pictures in this slide show an open bridge rail, both here at the top and in the bottom. So this is a bridge rail that will meet current safety standards. Finally, the width of the bridge will be widened slightly to 24 feet. Currently, it's about 22 feet. 24 feet is the minimum standard for this location. The bridge would improve hydraulic performance. As I mentioned before, we would want to increase that span to be 20% wider than bank full width. So we would have a structural span that's 39 feet and a clear span from face of abutment to face of abutment that's 36 feet. This bridge will allow water to travel below the beams with a minimum of 1.7 feet of clearance during a 100-year storm. So that gives the river room to carry debris without hitting the side of the bridge. The freeboard would be improved from 1/2 foot to 2.2 feet, and the backwater elevation will decrease from 1.8 feet to just 1/10 of a foot compared to natural conditions. The aesthetic of the bridge will also be improved. The project proposes using concrete form liners to simulate stone, both on these end blocks as well as on the wing walls. So this photograph here shows a photograph of what concrete form liner looks like with some staining. And the bridge would also have this 3-tube bridge rail, which would be metallized to a color of the town's choosing. This next slide shows the bridge plan. To orient you to this plan, north is actually to the right. So if you were traveling from left to right on this page, you would actually be heading northward. The bridge is indicated in orange. And the first thing to note is that we have our 36-foot clear span and our 39-foot structural span. So that span is getting longer than what's currently there. And the way we're achieving that is by holding the location of the north abutment and shifting the south abutment further to the south. In this plan, gray indicates the substructure. So you can see our substructure is U-shaped on both the north and the south approaches. The tan and green areas show places where the ground is going to be resloped. If you recall the photo with the concrete blocks, the proposed design will make those slopes less steep. And so things like those concrete blocks will no longer be required. Finally, you'll notice that there's a gravel driveway that is being relocated. This is shown in the plan, but that will need to be coordinated with the property owner once the design is progresses a little bit further. This next slide shows an elevation view of the bridge. From the east, the bridge superstructure is highlighted in orange and the substructure is highlighted in gray. The thing to note about this elevation is where the 100-year stormwater elevation lands. So you can see it's up here, providing that 1.7 feet minimum clearance below the bridge. The second thing to note is the support of the foundations. So as I mentioned before, our bedrock on the south side of the bridge is significantly higher. So we have that footing up here shown directly on bedrock. And at the north abutment where the bedrock is lower, we have piles that extend from the top of the pile cap down to bedrock. This is a cross-section of the bridge. On this one, the things to note is that the roadway is 24 feet wide from curb to curb and is comprised of 2 10-foot lanes and 2 2-foot shoulders. The open bridge rail will sit on a concrete curb, and the roadway will be comprised of 3 inches of bituminous concrete over a waterproofing membrane that in turn sits on top of a minimum 6-inch concrete deck. That concrete deck is then supported by our adjacent deck unit bridges. These circles, if you're curious about that, in our adjacent deck units are actually voids that help reduce the weight of the structure. This slide shows the roadway plan. Similar to our bridge plan, north is to the right. The length of our project site is about 500 feet. It's about 270 feet to the south and 230 feet to the north. The other thing about this plan is that it shows that we are essentially maintaining the alignment of the roadway. It's not shifting to the east or to the west by any significant amount. This is the roadway profile plan. The scaling of the drawing is exaggerated, but there are two things that are important in this plan. First, it shows that the 100-year storm passes below those new beams. And the second thing is that similar to our horizontal alignment, our vertical alignment is not really changing either. So we're not raising the road or dropping it any lower. During the construction of the new bridge, traffic will be detoured around the project site. There is a primary detour route to the east, which is in red, and a secondary detour route to the west. So the detour to the east uses Hampton Road and Ye Old Wyndham Road, Deerfield Road, and Bremen Hollow Road. The detour to the west uses Hampton Road, Pomfret Road, Eastford Road, and Boston Turnpike. A detour was determined to be the best way to handle traffic during construction. When the road is fully closed, it allows for faster construction. Temporary bridges are sometimes used, but this has significant environmental impacts, and so that was an option that was ruled out. And this bridge is also fairly narrow at 22 feet wide, which makes doing staged construction where you build one lane of the bridge at a time and then switch over and do a second lane of the bridge later, not really feasible. If this bridge was a wider existing structure, that might have been a more feasible option. But for this project, the plan is to use a detour to construct the bridge. There are no utilities on the project site. As I pointed out in the photo before, the overhead utility line stops south of the bridge. In terms of environmental impacts, those will include tree clearing. And the work of installing the new bridge will also have both temporary and permanent impacts on the wetlands adjacent to the river and to the river itself. The permits that we are expecting for this project include the Town of Pomfret Inland Wetland Permit, a Connecticut DEEP Flood Management Certification for municipalities, and finally, a U.S. Army Corps of Engineers self-verification form. The property impacts of this project will not include any permanent property takes. There will need to be easements in order to do some of the grading. Those impacts are primarily to the south of the bridge. Again, orienting you to this slide, north is to the right. So those impacts will primarily be to the south of the bridge, although there are some additional impacts to the north of the bridge. Both of these are mostly on the east side. We'll also be looking to get rights in order to install sedimentation and erosion control, and potentially to reconstruct the driveway that is currently east of the bridge. At this time, I'm going to turn things over to Kathleen, who is going to talk a little bit about the role of the Division of Rights of Way on this project.
Thanks, Rochelle. So my name is Kathleen Erickson, and I'm an Assistant Project Coordinator with the Department's Division of Rights of Way. And our office is responsible for acquiring the property rights that are needed for transportation projects. As just mentioned in this presentation, this project will require the acquisition of property rights. So I'd like to give you just a brief overview of our acquisition process. But before I go further into that, I do just want to mention that the specific property impacts for this project are still being finalized and may change as the design progresses. Also, any required property rights that will be acquired are going to be acquired in accordance with Connecticut General Statutes 13A-73 and 13A-98E, as well as the Uniform Act. Let me go to the next slide. So the right-of-way acquisition process begins once the design has progressed to a development milestone and all the impacts have been determined. At this point, each affected property owner will receive a formal letter of intent to acquire from our office, along with a property map which depicts the exact property rights to be acquired. And on the slide here, you can see a sample property map of what that might look like. Next, our office will determine the fair market value of those property rights, which will be used to establish an offer of just compensation. That offer will be sent out to the property owner in writing, and a right-of-way agent will be available at that time to meet with the property owner and to explain the project, go over the specific impacts to their property, and to explain the state's offer. The property owner will have a reasonable amount of time, typically about 30 days, to consider the state's offer and to enter into negotiations. Once an agreement is reached, the department will prepare all the necessary paperwork to record the deed and the property map on the town land records. However, if an agreement cannot be reached, in order to keep on schedule, the department may acquire the necessary property rights through its power of eminent domain. In that event, the state files a notice of condemnation in the Superior Court, along with a monetary deposit in the amount of the state's offer. The owner would then have 6 months from the date to file an appeal if they felt that the state's offer was inadequate. Whether or not the owner chooses to appeal, the money deposited in the court is available to be withdrawn by the owner at any time. It is important to note that the state only requires property rights that are needed for the project. If there are any questions regarding the right-of-way acquisition process, I'm happy to answer them during the Q&A portion of tonight's meeting, but for now, I'm going to turn it back over to Rochelle to continue the presentation.
Thank you. This last slide that we have for our formal presentation is related to the project schedule and cost. In terms of our schedule, we're looking for construction to start in the spring of 2026. That is subject to permit approvals. And our construction duration is anticipated to be one construction season, which is about 8 months, starting at the beginning of April, continuing until the end of November. Our construction cost at this time is estimated to be $2.45 million. That money will be will come from 80% federal funds and 20% state funds. So this project has no cost to the town. Please note that the cost and the schedule are preliminary and are subject to change as the design progresses. At this time, I'm going to turn the presentation back over to Mark Burns, who is going to facilitate our Q&A session.
Great. Thank you, everyone. Thank you, Rochelle. Thank you, Kathleen. As Rochelle stated, we'll now turn over to the question and answer session. As we stated previously, and I'm shown on the screen, you can reach us in different ways through email at dot.flbp@ct.gov, by phone, or by using the Zoom Q&A chat. If you have a question that comes up later, you still have our comment period is open until October 31st. And we also encourage you to fill out the voluntary survey as well.
I guess I'll ask a question.
Sure.
I'm just curious how that process works. Do the old abutments, are they taken out of on site where they are right now? Are they removed?
Yes, you're absolutely correct. So what will happen is the contractor will go out and they will most likely start with demolition of the superstructure. So they'll remove the parapets, they will create saw cuts in the superstructure between the beams, and they will then lift those pieces out. Once that upper portion of the superstructure is removed, the contractor then has room to drive sheet piling. Unfortunately, I don't have a photograph of that to show you, but they basically look like very large corrugated metal sheets, and those get driven into the ground and they provide soil retention, and they also keep the water in the channel. And so once those are in place, the contractor then has the ability to go in and actually excavate and pull out all of that concrete. You know, they break it up into chunks and pull it out in pieces. And that work can happen behind those sheet piles away from the river, and it makes room for the new superstructure, or the new substructure that will then replace it.
Great, thank you, Rochelle. We have a question that's come in from Elizabeth. Can you elaborate on the changes, both temporary and permanent, to the flow of the brook in the wetlands? We have Scott Young from CHA, who is their hydraulics engineer. Scott, if you can answer that question, please.
Hi, good evening. That's a good question. As far as the flows to the brook or to the wetlands, there really aren't any changes anticipated. The bridge is just going to open up the area to allow the water to flow through. We're not really increasing any significant amount of pavement, and there's a little bit more pavement out there, but not a measurable amount of pavement for this size watershed. It's a very large watershed, so you're not going to see any changes from that standpoint. So for the brook, there won't be any permanent changes or temporary changes. It would just be the fact of what Rochelle was just describing, where the brook will get narrowed down for just during that season where the construction's happening. It still won't change the flow of the brook. It may just make it back up a tiny bit upstream during the construction if there were a bigger storm. And as far as the wetlands, usually, wetlands are a discharge point for water, so we're not really changing anything from that wetland standpoint. Matter of fact, most of the wetlands are outside of any of the areas that we're impacting. We're really just going to be in the water course itself.
Great, thank you for that explanation, Scott. You're welcome. We're going to give it a couple more minutes if anyone else has any questions. Who will? I think Elizabeth has another question, but you may have hit enter before you finish typing. There you go. Who will manage the road closure? Thank you. Rochelle, can you take that question?
Sure. So the contractor is the one who would set up the barricades for the road closure. They would also install the signage telling people who are approaching the roadway, both on Taft Pond Road as well as prior to Taft Pond Road, that there's a detour. So they're the ones who are really responsible for the physical barriers and making sure that that road is closed off. In terms of managing the road closure, that also is going to be somewhat helped out. We'll rely on the town a little bit to get the word out when that closure is going to start. Typically in our contracts, we require the contractor to notify the town 30 days in advance of closing the road so that there's plenty of time to get that word out to everyone. Please let me know if that doesn't fully answer your question.
Great. Thank you, Rochelle.
We've had some experience with that when we had to close the bridge in 2021, and we did publish the closure on the town website, in the local newspaper, and on the radio station in Putnam. So that's probably the course we would take in this case as well.
Great. It's always good to be informative. We have a question from Barry. Will DOT provide business detour signage for the 4-H camp? That's definitely something that can be incorporated into the contract and into the detour signage. As we get further in design, we can coordinate with the town to see what type of signage that you're looking for and provide that.
I think the concern is that we have parents bringing in kids, dropping off kids at the camp and picking
Mhm.
kids up every weekend. So it would be very helpful to have a clear detour route mapped out and flagged, posted.
Sure. And we can even look into providing some kind of a handout or something to the 4-H camp that they can give to the parents as well, so that way they're aware what the detour route is.
Yeah.
Right. Another question from Elizabeth. We had significant damage done to the pavement of our driveway when vehicles turned around last minute on our property. Better signage is needed at the south entrance of Taft Pond. Yeah, we can, Jeff LeMay, if you're on, we can talk about signage a little bit.
I can speak to that briefly. We did post the road as closed and we did put up barriers on there. We just had people that defy defy
Right.
the notices that are put up. I mean, we have that happen all the time. I don't know. I guess they do it once and they figure that the road is really closed, but it is irritating to the residents that have their driveway used repeatedly.
Right, and during construction, there'll be advanced signing, there'll be advanced construction barricades, there'll be, if needed, message signing to let people know that the road's closed. We can do everything that we can to ensure that.
Yeah, I don't really have a lot more to add, Mark, but I guess if you could give us your address, so we know exactly where the issue was, we can make sure that you know, we can add additional signage or barricades or whatever's necessary to prevent that, you know, with this next project.
80 Taft Pond Road, Jeff, if you want to.
Yep, got that.
Perfect. Thank you.
Jeff, I believe that is the property that is to the southwest of the bridge.
Okay. Very good.
You're welcome, Elizabeth. We appreciate all the questions. If anyone else has any other questions, please do so. In the next couple minutes, we'll be wrapping up. If not. Okay. I think with that, we can conclude the informational meeting and the questions and answers. If you have any questions that come up following this meeting, you can reach out to us via email or through the portal, or you can even reach out to the town and she can relay messages to the project team and we'll be able to answer it. Thank you very much and have a pleasant evening.
Thank you.
Thank you.